Gain control of cyber risk with Tenable.io, the first vulnerability management platform built for today's elastic assets like cloud, containers, and web apps. Discover a fresh, asset-based approach that prioritizes vulnerabilities while seamlessly integrating into your environment. And improve ROI with the first elastic licensing approach based on assets, not IP addresses. Tenable.io delivers the data and context you need to secure your elastic attack surface. Start your free Tenable.io trial today by visiting Tenable.io. Onapsis is the leading provider of solutions to protect ERP systems from cyber attacks. Customers can secure their SAP and Oracle business-critical platforms from espionage, sabotage, and financial fraud risks. Visit them on the web at onapsis.com. The SANS Institute, the most trusted source for computer security certification training and research. Visit SANS.org to explore their full curriculum and latest training offerings.
And welcome back to the show. Yes, I'm not Paul. Paul had to go laptop shopping. He couldn't take it anymore. Jeff. All right, but before we get to the next segment, we've got a couple announcements. First up, go to itpro.tv/Security Weekly and use the code SW30 to try it free for 7 days and receive 30% off your monthly membership for the lifetime of your active subscription. That's pretty damn good. To learn more about IT Pro TV's team solution, sign up for a free demo of their supervisor portal. Pretty damn neat stuff. All right, and whether they're phishing or hacking or spying, threat actors use domains and IP addresses to launch their attacks. Yes, they do. And while you might not be interested in targeted attacks yet, targeted attacks are interested in you. Your ability to map the character and characterize the attacker's infrastructure is critical in defending yourself. Join Domain Tools senior security researcher Kyle Wilhut and director of product management Tim Helming on a virtual ride-along using Domain Tools Iris. They use real-world cases to show you how you can quickly and efficiently expose the adversary's infrastructure. Join the webinar at domaintools.com/Security Weekly. Learn how to protect yourself against various crime, espionage, and or hacktivism by seeing how the investigators and threat hunters work in the trenches. Visit domaintools.com/Security Weekly and see how you can recognize the staging area of the next attack. Pretty damn cool stuff.
Cool.
All right. So now that's out of the way. Let me put this keyboard back over here and let me grab this keyboard because in my tech segment for this show, I want to talk about something that I had a problem. I have lots of problems, but I had a technical problem that I needed to solve.
Let's limit it to one specific problem.
I had a technical problem that I needed to solve. And Josh Wright and I are putting together this brand new Capture the Flag scenario for our brand new debut of our SANS Wireless pen testing course. Coming up in a couple weeks here in Vegas. And in part of putting that through, we've got a bunch of challenges that you need to go through. And one of the challenges that I need to go through was the ability for the students to answer some questions based around a packet capture that had some very specific characteristics. Like they needed to find a packet in the middle of all this noise to be able to make something happen. The problem is it's a wireless packet, so potentially I needed to capture it. And in order for me to capture it, it needed to be for this very unique wireless network name with a specific MAC address and coming from a specific source and to a specific transmitter address. And
so not just any packet, but a particular
packet, a very specific set of packets.
Okay.
Yes. Okay. And I thought about this problem, and I'm like, well, great. I can go to the basement, and I can get one of my access points, and I can upgrade it to DDWORT, and I can change the MAC address, and I can grab a Linux client, and I can change the MAC address. And I'm like, damn, that's a lot of work. What if I craft these packets in Scapy? I only need one. I can create one packet in Scapy with all these characteristics and write it to a PCAP. Done. Well, now for the packet capture challenge, that's not very interesting. Or the packet analysis challenge, because there's one packet in this PCAP. So I wanted a lot of noise around it. But I went and looked at doing some fuzzing with Scapy to generate a whole bunch of noise, and it was the only properly formatted packet in the entire capture.
Right.
So I thought about this, and I asked Josh, do you have some just random wireless packet captures that you've got laying around from like the last time you went to Starbucks? Because all of my stuff is associated with a client and NDAs and stuff. I can't do that. Mm-hmm. He's like, oh yeah, I was at Starbucks a couple weeks ago, and I just captured a bunch of traffic. Would you like it? Yes, I would. The problem that I had is that I wanted to insert this packet into the packet capture somewhere. The noise, I want to take my one packet, my PCAP with one packet, and insert it into this large capture of noise. Mm-hmm. And I'm like, how am I going to do that? Well, I can read it in with Scapy, and when I get to some random number between one and packet number between one and I can insert this new one, and then I can read the rest, and then I can write it out. I'm like, that's going to take me like 2 days. And I talked to my good friend Mike Poor, who does a lot of Packet Ninja stuff, one of the former instructors for 503, the IDS class. And he says, use EditCap and MergeCap. I'm like, well, I can use MergeCap, but it will do that based on time. And the capture that Josh created was a couple months ago. And the capture I created was like 2 days ago. And then my packet's going to be the last one. Mm-hmm. He says, use EditCap to edit the date and timestamp on the packet you created to just put it in the past.
Right.
Then merge them, and then your packet will be interleaved in the other packet capture. And I'm like, this could be helpful. Someone else might like to know how to do this. So let's see how to do that. All right, so first one up, terminal window for us to do some edits to. But let's take a look at the packet captures first. So I'll use Wireshark to open up our specific packet. This happens to be a beacon frame, a wireless beacon frame, an access point saying, "Hey, I'm here," and it's for a specific wireless network, and the wireless network name starts with Romani. And there's a couple of them there. But this, let's see here, looking at the frame, it has an arrival time of October 7th, 2017 at 16:48:52. That's when the packet was allegedly generated.
Which in theory is highlighted down in the hex somewhere, right?
Yes, it is. So yeah, absolutely. If you click here, it's highlighted down in the hex somewhere here. Yep. Oh, okay. Wait a minute. It should be. I have the screen blown up really big, so
right.
But
it's there. Trust us.
It's there. Any case, so the time is here, and let me make sure this is the actual time because I will screw this up. So great, we've got a date for when the packet was allegedly generated. Mm-hmm. All right, so we've now also got this packet capture full of noise. This one takes a little bit longer to open because
there's more data.
It's a heck of a lot more data. So now we've got a whole bunch of other wireless packets. And let's pick a time looking for this, say right around packet 500. Let's say we want it to show up somewhere right about packet number 500. I could have used the go to packet 500, but I'm being lazy. And looking at packet 500, looking at the header, the arrival time was June 15th, 2017. I picked this at random. I'm like 500 seems like a good number, and the time it arrived was 13:37. Mm-hmm. It's pretty late. Okay, 13:37 in 1 second.
You didn't plan this.
I actually didn't. I just I'm like, 500 is a good round number. That's pretty cool.
That is cool.
So now, in order to
it's a good omen.
Exactly. So now, in order to get our beacon interleaved into this packet capture, somewhere around packet 500, we have to figure out the number of seconds different between the two sections. So the arrival time for the beacon and the arrival time for where we want to insert it in the noise. Mm-hmm. So I cheated. I went to this lovely website called Date and Time. Is this it? Yep. timeanddate.com, and it allows you to calculate the duration between two dates. And I plugged in those dates, 7/15/2017 and 10/7/2017.
Now, out of curiosity, why does this website exist? Why would people want to know the delta between two times?
Lots of reasons.
Give me one or two.
How many seconds have I been married to my wife?
Yeah, wedding anniversary.
Lots of reasons.
When will this be over?
Yes.
Oh wait, it's that old Meatloaf song. I'm waiting for the end of time.
Yes. Now
Okay.
waiting for the end of time.
Gotcha.
So, according to the calculations, and I'm doing this live and didn't have a chance to sort of practice really beforehand, it claims that there's 7,269,110 seconds between those two dates. So if I take that figure and I now go and I adjust my beacons,
Okay.
so I'm going to use edit cap to edit my packet capture. And this will apply to every packet in the capture. It will shift the time by this many seconds. I've
Okay.
only got one packet. We can apply it to specific packets in the capture. We can
Right.
apply it to all of them. This will do all of them. And we're going to shift the time back 7,269,110 seconds
Okay.
back, the negative. So the negative. We're going to read from beacon.pcap, and we're going to write that to TO.pcap.
I have to believe that's not really seconds. That's probably like
It's seconds.
It is seconds.
It's seconds.
7 million seconds
7 million seconds.
is how many hours, days, weeks off the top of your head.
Yeah, I'll tell you.
Tell me.
Not off the top of my head. It is, in fact, 84 days, 3 hours, 11 minutes, and 50 seconds.
Okay.
Thank you, timeanddate.com. All right, so let's do that. It goes and edits the packet capture. So now we should have to.pcap, and let's see if this actually worked. It now says the arrival time was July 15th, 2017 at 13:37:02.
Okay.
If you remember, packet number 500 was July 15th, 2017, 13:37:01.
Right.
So this should show up shortly thereafter, packet 500. Now, we can definitely get down more granular into microseconds to make this a little bit more accurate, but for demo purposes, we'll do it in this
Well,
one.
if it happened to duplicate an existing packet, do you know how that would be handled?
I don't. And
Hopefully that doesn't happen.
Right, and I think EditCap would probably find a way to deconflict those
Okay.
two issues. So we've edited the PCAP. We now have TO2.pcap, and we've got our noise. So let's merge those two together, and we can do that with merge cap. So we're going to use merge cap. We're going to write out a combined of the two. So I'm going to write out combined.pcap, and the source is going to be noise and TO. So we're going to write those two together and into combined. We could do this with multiple. We can set timestamps for a bunch of them. And merge cap by default will merge them based on time.
Okay.
You could do it by packet number. You could do it by a bunch of different stuff. I'm choosing to do it by time, by the default behavior. So if we do that, it's going to take a little bit longer, not by much, as it knows where to insert that. So now we should have a combined.pcap.
And now this is the whole point of the CTF is to find that packet.
Right.
Okay.
Now, that said, this is strictly for demo. The packet you actually have to find is different.
Gotcha.
Because this was my testing to make sure it actually worked.
So it won't be a beacon packet in the real CTF.
It might be a beacon packet in the real world, but...
Pay attention.
Right. So if we look at 500, looking at our headers, that was 1301. And we've got some beacon frames here, which, of course, is going to be a pain on me here. Let's see here. Wets. So we've got a bunch of beacon frames. We were looking for one specifically related to a beacon frame with an SSID of starting with Romani.
Does Wireshark have the ability to search?
It does. All right, so there's the SSID parameter set for this particular packet. Roman tile, no Roman tile. Oh. Okay, Roman tile. Watch, I did the calculation time wrong. But, so let's filter this. So we know the frame contains that phrase of Romani. So I'm just going to search for Romani in that. And sure enough, it found the packet and it put it at the very end. Oh, well, that's interesting. So what did it put for the frame header? Arrival time, July 15th, 2017.
Did you do the edited file or did you do the raw file? Looks like you did the raw file.
Oh, no. The merge cap. The merge cap was noise and TO. TO was the output. Beacon was the source. We wrote to TO.
Open up the TO again?
Yeah, let's open up the TO again. This is what happens when I get asked right before the show to do this, and I didn't have it practiced. All right, so there's TO. Unless I did it based on the wrong time calculation. Nope, because that's the only time that's there is in that from the interface. Yeah, that's fine. Encapsulation, arrival time. That should have done it.
Can you do it by epoch time? Yep, epic time?
Epic time? Well, let me try this here. Let me,
Maybe it wasn't truly random.
apparently.
You needed entropy.
That's right.
Well, let's try one of my other examples here.
If nothing else, this is how to create a CTF.
Yeah. All right, so let's try this one. Let's change it by this value, because maybe I mistook some calculation here. So let's do edit cap. We'll give it 4,930,120 seconds in the past. Take beacon and overwrite TO pcap.
Okay.
And now let's take TO. Here's the new one.
It's August 11th.
1520 this time, as opposed to 1337.
But August 11th.
Yep, August 11th, which is very strange. Maybe I changed my damn file to begin with. Let's open. Oh, I got to do this first. I got to merge it. I bet I started with the wrong source file. Let's do the merge cap to write combined from noise to
Yeah,
pcap.
because you were looking at history, not combined or something like
Yep. I bet I used the wrong source. Well, let's try this again real quick here. But you're going to get the general idea. So now let's go to combined. Frame contains Romani. Where does it end up? At the end again. Huh. Interesting. Oh, you know what? You know what I did?
What you did?
The source file that I started with, I think I time shifted already from when I did the original calculations. You get the point. You can time shift packets using edit cap to put them based on the same time frames where you would want them normally in a packet. Apparently, having 10 minutes to prepare this from source files that weren't necessarily the right ones didn't work out so well. But and certainly when I go back and do this and document some of this in the show notes, we'll actually make sure it works. But the important part is calculating the time from where the packet that you want to insert is to where you want to insert it in the packet capture, and figuring out the number of seconds and in which direction.
Right.
Dumb question. Let's do this real quick here. I did in the past for this. What happens if I do it in the future with a plus? Do the merge cap. And then let's look at the combined.
Oh, maybe you went in the wrong direction.
Maybe I went in the wrong direction. Same. Still at the end. Yep, my time is off. In any case. Still, I thought that was pretty darn handy. If you are potentially, Wireshark. All right. So I thought this was particularly handy for a number of reasons. One, what happens if you're gathering PCAPs from two disparate systems that you want to combine? MergeCap is a pretty darn neat tool to be able to do that, especially if you're capturing at the same time. You can get those two packets interleaved from two different sources. Some other ones that I thought were pretty neat for some potential options were doing something like a CTF, or where you needed to actually have some specific packets crafted in specific times. Now, that said, we probably could have used Scapy to timestamp those exactly at the right time that we wanted to. But that would have been a heck of a lot more work than using some command line tools, because I live in the command line as opposed to Python all the time.
I want to go back to the website and figure out how many seconds either I've been alive or I've been married. What was that website again?
Timeanddate.com.
Timeanddate.com.
Yep.
I'm going to play with that later tonight.
Is that the actual time or just what it feels like?
Is that Unix time?
That's a good question. It says it's 7:35, 36, 37 currently here based on our location. All right. Date-to-date calculator.
Date-to-date calculator.
Yep.
And do they use tick or tock as their time source?
That's a good question. I don't know. So Jeff, what in what month were you born?
I was born May 24th, 1962.
May
And
24th. Come on. 1962. Man, I got to scroll way back.
yeah, it might not go back that far.
And today.
Today.
Calculate duration. So if we just do no times involved in that, you've been alive 1 trillion 743,638,400 seconds.
Proving that I'm older than you.
This is very true.
How old are you, Richard?
We didn't need the seconds to prove that.
No, we didn't. Man,
Not quite as old. I think you beat me by about 9 months.
9 months. Okay.
20,181 days.
How many millions of seconds
and
did
you have all of this to show for it.
Am I older than Richard? There's one.
Yeah, you could do that. You do between birthday and birthday.
Yeah.
But let's not do that.
Yeah, we won't do that.
Yeah. So, concluding this tech segment, some pretty fun stuff with sending packets back in time, or potentially forward in time, depending on which direction you want to do that. And inserting those two packet captures with merge cap so that we can interleave packets and hide stuff in packet captures, so to speak.
Would there ever be a reason, like if you were a bad guy, and you, or even maybe in some of your pen testing activities, and you had the ability to gain access to any kind of logs, would there be an advantage to trying to throw people off the trail by going in and editing timestamps on certain of your activities?
Sure. So thinking about that, just the first one that comes off is that if we're doing packet captures for logon and capturing logon off events, we could potentially, let's say, use an open protocol POP3.
Okay.
You can observe logon and a quit, logon user pass quit.
Right.
What happens if I were to insert on their full packet capture solution in PCAPs user pass quit? A logon user pass quit type of thing. When in fact it was user logon retrieve a bunch of mail,
Right.
then quit.
Right.
So if you start analyzing some of those
So
connections,
move the logon and the quit closer.
move the quit
inside
to say,
of wherever you were doing whatever you were doing.
Right. So that, depending on the tools you're using that they're doing the analysis for start and stop of communication, and they see the quit based on the protocol as opposed to the TCP session.
Right.
You could, something like that.
We're trained professionals. Don't try this at home.
Or do.
Or do.
Or do.
To your heart's content.
Yes. All right. So with that, gentlemen, let's take it on to Stories of the Week.
All right. We'll be right back.